Hello class, and welcome to your second lecture on bitumen and asphalt. This will actually be your final lecture for this semester. For week 9 there will be one more lecture, but that will be a review of everything we've done, and we will be doing that by Zoom, and that will prepare you for the online exam that's coming up in a couple of weeks' time. So please be there for the Zoom meeting next Thursday. This is your final lecture, and this will finish off what we covered in bitumen and asphalt starting last week. So last week we talked about certain kinds of bitumen. We talked particularly about the distinction between tar and bitumen and asphalt, and we also talked about cutback bitumen, and we also talked about emulsified bitumen, which is the more common kind of bitumen these days. Now, today we're going to be looking at certain properties of bitumen, and with that we'll also be talking about testing the bitumen. So a certain property of bitumen is the obvious one, that it's water resistant. It's made from oil, and that's why we use it for roads, because it creates a nice waterproof barrier over our roads so that rain and snow can't erode the road. But there are other properties. Viscosity we'll be talking about, and also fluctuations in viscosity with temperature. And then the final property we're looking at is a property called ductility. That's about how stretchy a bitumen is, and that's got an important property to play too in asphalt road surfaces. So let's talk about viscosity first. Remember, if a liquid has a very high viscosity, that means it's really thick and runny, something like honey. But if it's low viscosity, that means it will run considerably, and it's something similar to wine. So wine has a lower viscosity than water. Honey has a higher viscosity than water. Now, if a viscosity is too high or too low, the bitumen will be unworkable. That's understandable, isn't it? If it's too high, it's not going to be nice to mix the aggregate into the bitumen to make the asphalt. And if it's too low, basically all of the aggregate is going to sink to the bottom of this very low viscosity liquid. Now, one of the things you've got to realize is that viscosity has a variation with natural bitumen. Remember, bitumen is basically hydrocarbons that have a carbon chain of between 70 to 200 carbons. And basically, the longer the carbon chains, the more viscous the bitumen will be. Now, the natural viscosity of the natural bitumen, that will determine how much cutback, how much kerosene you add, or how much emulsification, how much soap you need to add to the bitumen to get the right amount of viscosity. Now, the other thing you need to know is that viscosity will actually decrease with the temperature. As the temperature goes up in the summer, the viscosity of the bitumen will decrease. The bitumen will get more runny. So some of you may have experienced this. Have you ever gone for a walk on an asphalt road in the real heat of summer when it gets really hot? And the road sort of gets sticky because the bitumen has lowered in viscosity and it's sort of become liquid. You've got this sticky bitumen on top of the road surface. But you don't get that in the winter. In the winter, the bitumen is hard and semi-solid. It's got high viscosity. So you can see a variation in bitumen with temperature. It is inversely proportional to temperature. As temperature increases, the viscosity decreases. It becomes more runny. Now, how do we test bitumen's viscosity? Well, it's a kind of penetration test. If you can imagine, if I was to drop a spoon into either the wine glass or the honey pot, the spoon is going to sink into the wine at a faster rate than the honey. And so Bowen, who was a lab assistant many years back, he developed a penetration test for testing the viscosity of bitumen. Now, there's a video of the penetration test, Bowen's penetration test, on Moodle. I've given you a link. It's a YouTube video. But basically, this is the standardized penetration test for testing viscosity of bitumen. So remember, if basically if you were going to be spraying bitumen onto a surface, if it was low viscosity, it's going to basically sink into the ground because it's very liquid. If it's too high a viscosity, it's going to clump on the surface. And then it's going to wash away as soon as you have cars driving over it, because bitumen in and of itself has no strength. But if it's the right amount of viscosity, it's going to mix in with the aggregate just the right amount, and that's going to create a nice strong and waterproof surface on the road. So yeah, this is Bowen's penetration test. You've got to conduct it at normal temperature. So remember, the temperature as temperature changes, that actually influences the viscosity. But basically, you can see there you've got a small pot of bitumen, and you have above it a needle, and that needle has a weight of 100 grams above it. And basically, you drop the needle, and that 100 grams will push the needle into the bitumen for 5 seconds. And it's measured in units of 0.1 millimeters, so it's a very fine measure. So if it goes 15 millimeters into the bitumen over 5 seconds, then it has a viscosity of 150. If it goes 3 centimeters or 30 millimeters into the bitumen, it has a viscosity of 300. And when so this is for wet bitumen, for an emulsified cutback bitumen where it's highly workable. But after it's cured, meaning after all of the soap or the kerosene evaporates, the viscosity of the hardened bitumen should be around 10 to 70. It should the needle should sink into it between 1 to 7 millimeters. And so obviously the smaller the number, the more viscous the bitumen is. So remember, that's what we want. We want it to have a viscosity. If it's emulsified or cut back, we need it to be around 150 to 300. And that means it has enough workability. But when it's cured, meaning after the soap or the kerosene evaporates, it's going to have a much lower viscosity, be about 10 to 70, and that means it's going to be strong. We need it to be strong for it to last. So remember, fluctuations in viscosity can emerge with temperature. As the temperature gets hotter, the viscosity decreases. As it gets colder, viscosity increases. Now that doesn't really matter in a lot of places, like New Zealand, where the temperature outside is very temperate. There isn't really a big difference between summer and winter, but it's of utmost importance in Kurdistan. Kurdistan has very cold winters and very hot summers, and so we need to account for the fluctuation in viscosity of bitumen throughout the season. Now, look at that graph I've shown you on the right. You've got two bitumens there, bitumen A and bitumen B. Now, where they cross over, at that temperature, they have equal viscosity. But as the temperature gets hotter, A becomes less viscous at a faster rate than B, and so it turns to a liquid faster than B. And as it gets colder, A will become more viscous, meaning it will go harder at a faster rate than B. So this is a problem for bitumen A, because what happens if a bitumen is too viscous, it becomes too solid and too hard, it can become brittle, it can crack, and that means you start getting potholes in your road. And if it becomes too liquid, it loses its viscosity, it turns to a liquid, and that liquid basically bubbles to the top of the surface and it washes away as cars drive over it. And so you get potholes forming then. And so in a place like Kurdistan, you want to get a bitumen that does not have a big variation in viscosity as the temperature gets high or low, because if the viscosity gets too high, it'll get brittle, and if it gets too low, it will basically run off the road. And so that's important. So potentially in a place like bitumen B, for a place like Kurdistan, you want to use a bitumen like bitumen B, which has less variation in viscosity than bitumen A, even though at a temperature X where they cross over, they have the same viscosity. So this is what happens. You've probably seen this on some of the roads in Kurdistan. In the height of summer, when the temperature gets really hot, basically the viscosity of the bitumen drops really low and it turns to a liquid, and basically all of the aggregate sinks to the bottom and you get these shiny areas on the road where the bitumen is just sticking to the surface. That's going to wash away as soon as it rains and as soon as car tires start wearing it away. And so that's a big problem. That can cause potholes in time, because basically once the bitumen is washed away, you're just going to have aggregate, and water can get in between the aggregate in the voids, and that's going to create big holes underneath the wearing surface of the road. So that's a picture of a pothole. It's the unofficial symbol of the KRG. Part of the reason you have a lot of potholes in Kurdistan, we'll talk about a few different reasons why there are a lot of potholes later, but one of the reasons is because bitumen often has too much variation in its viscosity. In the winter it can crack and become brittle, and then water can get underneath, or in the summer it turns into a very runny liquid and it washes away. Both of those factors can lead to potholes. So what can we do to control this variation and fluctuation in temperature, in the fluctuation in viscosity? Well, there's a couple of different things. One thing you've got to remember is that if the hydrocarbon of your bitumen has long chains of carbon, like 200 plus carbon in the chain of hydrocarbon, it's going to have less variation than one that has fewer carbons in the hydrocarbon chain, something like 70. Obviously, though, you don't really have a lot of say in what kind of bitumen you get out of the ground. And so one way you can do this, one way you can control viscosity fluctuations, is you can mix rubber in with your bitumen mix. And you can buy a rubber powder. This is usually available at hardware stores. But this is a great way to stop bitumen having such a big variation in viscosity. This is what stops your bitumen from becoming hard and brittle in the winter and soft and runny in the summer. And so in a place like Kurdistan, really bitumen rubber should be used in every kind of asphalt road surface. because you have such a big variation in temperature. It doesn't matter so much in places like New Zealand or the UK where temperatures are pretty temperate, but it's very important in Kurdistan. One of the bad things is rubber is a little bit expensive. I think for it can add several $1,000s to the cost of material, and so that's one of the reasons why it often doesn't happen in Kurdistan, and therefore you have a lot of potholes. So that's fluctuations in viscosity coming about because of variation in temperature. The way to fix that is to have rubber in your bitumen mix. So another great property of bitumen is that it's an oil. That means it's insoluble with water, like all hydrocarbons. And that means when you mix it in with aggregate and you make asphalt, that makes a really good wearing course on your road. Now, one of the things that a wearing course needs, the wearing course I mean is the top layer of the road. Now, one of the things that the wearing course must protect the road from is rain. If rain was getting underneath the wearing course, it's going to start eroding the road away and taking all of the sand and aggregate away from the road, and that's going to cause potholes. So water resistance, very important for road wearing courses. So what are the factors that influence water resistance? So remember, you want your wearing course, the top layer of the road, to be waterproof, because if water gets through that, it's going to wash away the layers of the road that are underneath the wearing course, namely the base course, and they give your road strength. And so if that happens, you start getting big potholes forming in the road. So what causes a failure in the water resistance? Well, this is a failure in the water resistance of asphalt, but one of them is that aggregates can be removed because of shearing. So if an aggregate gets pulled out of the road, it's going to leave a hole in the road. And if that goes through the bitumen, then water will get through it. Now, an aggregate can break off by shearing. So can you imagine a car driving on the road and then braking suddenly? There's going to be a shear force between the tires of the car and the surface of the road, and that friction can actually break the aggregate particles out of the wearing course. Now, the other thing is where aggregates are just not properly coated in bitumen. What's the most expensive part in the asphalt? Is it the aggregate or is it the bitumen? It's the bitumen. And there does seem to be a tendency at times for a lot of contractors to not put enough bitumen in their asphalt mixture. The other thing is temperature fluctuations, where the bitumen can expand and shrink and become viscous and high viscosity and low viscosity. And so basically the bitumen can become brittle and crack when it's a low temperature, or it could become very liquid and wash away in high temperature. And both of those will mean that water can then penetrate into the wearing course. It breaks down the waterproofness of the wearing course. I now want to talk to you briefly about ductility. So ductility, what is that? Well, ductility is basically a measure of how stretchy a bitumen is. So imagine if you had a chunk of Play-Doh, and I grabbed the Play-Doh and I pulled it between two hands. The Play-Doh would stretch out, and it would stretch into a long strand of Play-Doh, and it will eventually break. Well, that's what ductility is. It's basically, if you look it up in in a dictionary, it might say something about how easy it is to make it into a wire, meaning how far can you stretch a material into a long, thin strand. Now that's very important because that basically is a resistance to brittleness. So it's very closely related to ductility. Ductility, sorry, is very closely related to viscosity. Generally, a high viscosity can lead to low ductility. So how do we measure this? We take bitumen and we stretch it, and we see how long it can be stretched before it snaps. Now there's a very standardized test for this called the D113, or the ductility test. You will be doing this when you do your transportation modules. Again, unfortunately I can't do this with you in building materials because we don't have a lab, but you will be doing this in due time with Dr. Abbas. Now, if the ductility is low, that will mean that the bitumen will break quickly and it will cause potholes. It will basically snap and it will be brittle. Now, normally you want to have at least 1 meter of ductility for road wearing courses. The other thing you need to know is that ductility increases with temperature. So I got that wrong. That should say increase, not decrease, that final point. Basically, as the weather gets hotter, the bitumen will get more stretchy and more ductile. Guys, I really want you to watch the video of the ductility test that I've put on Moodle, because that will show you what I mean by measuring ductility. But basically, any bitumen that we use for a road wearing course, we normally need to have at least 1 meter of ductility, meaning we need to take this clump, this standard shape and size of bitumen, we need to be able to stretch it at least 1 meter. So, what are potholes in Kurdistan? You've got potholes all over Kurdistan. Why do we have a lot of potholes in Kurdistan? Well, there's a few different reasons. One of the reasons is that you have a very high temperature variation in Kurdistan. So when it gets really cold in the winter, that means that the bitumen loses its ductility and it gets brittle. And then when it rains, water can get in underneath the road. Another thing is it gets very hot in the summer, which means the bitumen loses its viscosity and it turns into a big puddle of oil on top of the road, which washes away. And then you're left with aggregate, which has less bitumen, and so water can penetrate into the road there. Another reason is that maybe there just wasn't enough bitumen used in the asphalt mixture to begin with. Often there's a lot of cowboy or very stingy contractors, and a lot of engineers who don't watch what the contractors are doing, and so often the road becomes suboptimal because there's less bitumen. Those are all reasons for potholes in Kurdistan. So let's now talk about asphalts here a little bit more in depth. So remember, asphalt is basically a mixture of bitumen with aggregate. So just as concrete was a mixture of cement with aggregate, asphalt is a mixture of aggregate with bitumen. Sometimes asphalt is called asphaltic concrete, but this is what we mean. So remember, it's a mixture of bitumen and aggregate. Now, normally you want to have enough workability in your asphalt to be able to place it. So you need to make sure that it can be pounded into a shape, it's runny enough. And so the way you can increase the workability of your asphalt is you can actually use cutback bitumen or emulsified bitumen. The other thing you can do is do hot mix bitumen, because remember, the viscosity of bitumen decreases with temperature. So if you heat it up to about 60, 70 degrees, then it's going to have it's going to have less viscosity, and the asphalt is going to be more runny. The other thing is you've got to make sure that the aggregate particles in the asphalt are reasonably well graded. If they're not well graded, then you're not going to have workability. So remember, in an asphalt, typically about 75% of the volume is made up of aggregate, and then roughly about 20% of the asphalt is made up of asphalt. Made up of bitumen. So asphalt binder, that's bitumen, the glue that holds the aggregate together. And you have about 5% of air voids. You don't want it much higher than that, but you're always going to have a small amount of air voids inside the asphalt. So remember, when you've got an asphalt road wearing course, you've got a few different properties that you are trying to measure. Remember, you want to have pothole resistance in the wearing course, and that's influenced by the ductility, viscosity, and resistance to viscosity variation in temperature. Those are all properties we've already looked at when we looked at properties of bitumen. The other properties that influence pothole resistance have to do with asphalt properties, the amount of bitumen, that's very important, and also the grading of the aggregate in the asphalt. If it is poorly graded, then you're going to get big voids that are filled with bitumen that can be worn away by cars driving over it, because remember, the bitumen is quite soft, unlike the aggregate. The other thing is skid resistance. You need to have a road surface which is not soft and shiny and smooth, because otherwise that's dangerous. If a car is driving on that at high speed and it brakes suddenly because a child runs out on the road, it's not going to be able to stop. The car is going to skid. So what influences the skid resistance, the friction of the wearing course? Well, that's the type of aggregate, the grading a little bit, and also the shape of the aggregate. And then finally, shear strength. If a car is driving at high speed and then brakes suddenly, will it break aggregate out of the wearing course, out of the asphalt surface, because of the inertia energy, the shear force being applied to it? You want shear strength as well. So remember, with pothole resistance, it's basically trying to make sure that the asphalt road surface is water resistant. It keeps water from penetrating under the wearing course and then forming a pothole. So if you don't have enough bitumen in the asphalt, if it's below that 20-30% mark, you're going to start getting voids in the asphalt that water can penetrate. Not a good thing, and it's a very common problem with new roads in Kurdistan. They just didn't put enough bitumen in the aggregate mixture, in the asphalt mixture, and then after a few years, potholes start emerging. Also, if the amount is too high, if you have too much bitumen, all of the aggregates will sink to the bottom, and the bitumen will basically form a big shiny surface on top, which will wash away with rain or with tyres wearing it away. That can leave voids, that can lead to potholes. Also, if the aggregate is well graded and it has lots of fine particles, aggregate particles in it, that can stop that segregation. Remember segregation when we looked at concrete, where basically all of the aggregate sinks to the bottom and all of the cement and the water is at the top? Well, the same thing can happen with aggregate in asphalt. You don't want it sinking to the bottom, and therefore making sure the aggregate is well graded, that can actually stop this segregation, which would lead to potholes. The other thing is making sure that you have a reasonably high viscosity of bitumen in the asphalt. You don't want it too high, of course, otherwise you don't have enough workability. But if it's too runny and it's low viscosity, the aggregate will sink to the bottom. Now, normally the bitumen is about 20% of the volume of the aggregate. 70% or so, 75% would be aggregate, and then 5% would be air voids. So, skid resistance. Remember, there should be enough friction inside a road wearing course so that when a car brakes suddenly, it doesn't start skidding. So you need to have a certain amount of friction. And this is basically determined by the size of aggregate. The larger the aggregate size, or the largest aggregate size, the more friction you will have. Shape also has a little bit of influence, but let's just focus on size here. Normally, you need to have at least a 10mm minimum size aggregate. So normally on the high speed roads, that might be higher still. That could be anywhere as high as 20mm. Obviously, though, you don't want the largest aggregate size to be too big, otherwise it's not going to be workable. If you have big 50 to 100mm aggregate particles, it's not going to be workable. You're not going to get a nice smooth surface. So remember, as cars are continuously driving over the wearing course, basically the aggregates are basically being rubbed and they are being worn down. And this is because the aggregate doesn't have enough hardness. This can mean that the road starts to shine over time. Do you know what I mean by shine? I've got a picture there, but I don't think it shows it too well. But basically, if cars are continuously driving over the road, they're basically polishing the road and making part of the road really smooth and shiny. How do we prevent that? Well, we need to make sure that our aggregate has a high enough hardness. Do you remember studying hardness when we looked at aggregate and we did the Los Angeles test? And I said that an aggregate for a wearing course, meaning the aggregate on the top surface of a road, that couldn't have an abrasion value of more than 30% in Los Angeles test. Any higher than that and it would be too soft. It would wear away with cars driving over it. Now, there's a lot of standards on this. ASTM, Ausroads, these are all building standards, but they all have factors of how hard the aggregate must be in an asphalt used on a road surface. So, shear strength, this has to do with cars braking suddenly. So look at that car there skidding around the surface, around the corner. What's happening between the back tyre there and the road surface? What kind of force is being applied? Well, it's actually a shear force. They're forces in opposing directions but on two different planes. Now, the shear strength of the asphalt will determine whether aggregates start breaking out of the asphalt or not. And if that happens, you will start getting voids, and that can lead to potholes. So basically, to avoid this, you need to make sure that you have enough bitumen volume. The bitumen needs to be 20-30% or higher. That's very important. So this is an old road in Massif. I'm not sure, but can you see where the road has worn away there? Basically, cars are driving down that road and it's very steep, and they get to a corner and they're braking around the corner. And so in these places, that's where you're getting maximum shear force. And you can see what's happened there. The road, the wearing course, has worn away because of the shear force of the road. It happens there and not on the straight parts of the road, because on these corners, that's where cars are braking, and that's creating a shear force. And so that road is wearing away. It doesn't have enough durability because it didn't have enough shear strength. If they had a higher amount of bitumen, and also if the aggregate was better graded, it was well graded, that could have potentially have prevented it. The other thing that could prevent it is actually having smaller aggregate particles in the asphalt. So if the largest aggregate particles were smaller, then it would have more shear strength. Of course, it would have less skid resistance too, so it's a trade-off. So how do we get good workability between the bitumen and the aggregate? How can we place it on the road? Well, that's remember, you can mix the bitumen with an emulsifier, or in the olden days cut back like kerosene. But the other thing you could do is you could heat it up, and this would normally be heated up to about 60-70 degrees Celsius. And this is often done with aggregate bitumen and an emulsifier. They are mixed together in a batching machine, and they're heated up, and that lowers the viscosity and makes it runnier, and that means you can place it on the ground, and then it will be rolled out. A compactor will basically press out the asphalt in place. This works quite well, because also once it cools down, the viscosity of the bitumen will increase, and the hardness of the bitumen will increase, and that will mean that the strength and the durability of the asphalt road surface will increase too. So it's workable while it's hot, and then as it cools, it becomes hard and strong. So with HMAC, or hot mix asphaltic concrete as it stands for, that is by far the most common way that we use asphalt, where we basically mix the asphalt with the bitumen with a bit of heat and also an emulsifier, and then we mix it on site, and then we place it on the ground, and then we compact it. That is by far the most common way of doing asphalting. It's probably the 90% plus of all asphalt is done that way. But I want to tell you that the big disadvantage with HMAC is it's very expensive. And so this is a problem, particularly with a developing country like Kurdistan, but all countries actually. They don't want to spend too much money on their roads if they don't have to. Now, New Zealand is a country which it's about it's about twice the size of the KRG. It's actually a little bit smaller than Iraq, all of Iraq. And it's also a very long, skinny country, as you can see in that photo there, and it's split between two islands. Now, the thing with New Zealand is the population is very small. The population is under 5 million. And so because of that, there's a lot of kilometre of road for the given population. And so this is a problem if we use HMAC. So with a sparse population like New Zealand, you've got a problem. There's only so many people you can actually tax to raise money for the roads, and also you need quite a lot of kilometre of roads to connect everyone throughout the country. So how do you pay for that? Well, New Zealand needed to develop a way to bring the cost of roads down for the amount of money you spend per kilometre of road. And so they developed a new alternative to HMAC called chip sealing. And this is basically where the elements of asphalt, namely aggregate and bitumen, are not mixed together before they get to site and then placed on the ground. No, they're brought separately and then they're applied to one another in a special way. And I'm telling you this because I think there's a lot of advantages with chip sealing which Kurdistan could really benefit with. So I'm introducing this as another material, even though I don't think this actually exists in a big way in Kurdistan. This is, even though it was developed and invented in New Zealand, it's growing in popularity throughout the world. It's very common in South America, Africa. A lot of places in Europe are using chip sealing now, North America as well. But I think Kurdistan really needs to introduce this because Kurdistan doesn't have that much money and they also have a lot of roads that need to be built. So with chip sealing, you bring the bitumen and the aggregate separately to the site. Now the bitumen, it comes in a big tank and it might be heated up, and it's usually got an emulsifier in it as well, and so it's very low viscosity, and you spray the road with a film of bitumen, so you can see that in the picture. Now once you've got a film of bitumen on the road, a big sticky film, you will then pour a very thin film of aggregate on top of the bitumen. And then you would use a pneumatic roller, so that's a roller with rubber tires that will roll over the aggregate and push it into the bitumen. And then finally, you would then get a road sweeper, so a type of machine that basically brushes the road. So if there's any loose aggregate particles left over, they're pushed to the side of the road. Finally, you spray the road again with a second film of bitumen, and so then the aggregate is sort of held inside the bitumen like a bitumen sandwich. You've got a layer of bitumen, then aggregate, then bitumen on top. So what is the great advantage with chip sealing? Well, the real great advantage is that it is really cheap. Compared with hot mix asphalt, it could be around 10 to 20% of the cost. If Kurdistan used chip sealing for its roads, it would save millions of dollars every year. That's not an exaggeration. It would be tens of millions. The other thing is that with chip sealing, it basically works better if you use larger aggregate particles. Normally with hot mix, you wouldn't use aggregate particles bigger than maybe 10-15 millimeters in diameter. With chip sealing, usually it could be anywhere between sort of 25 to 40 millimeters in diameter. So if you've got a larger aggregate, that means it's going to have more friction, and so there's better skid resistance. So cars are not going to skid off the road, and potentially the road is going to be safer. There is also less tendency to bleed. What do I mean by that? Well, bleeding is basically where on a hot summer's day the bitumen loses its viscosity, and it also expands, and it bubbles to the surface and forms a big shiny black surface on top of the road, and then it washes away, and then eventually you're going to have a pothole there because there was no bitumen to keep the water resistance of that part of the road. So chip sealing, potentially in terms of water resistance at least, it's actually more durable than hot mix asphalt, potentially. So there's some good advantage, but the real big advantage is the money you save. 10-20% of the cost of hot mix asphalt, that is not to be scoffed at. But what is the disadvantage with chip sealing? Well, the big disadvantage with chip sealing is that aggregate particles, they tend to be less graded. They're more uniformly graded, and they can become dislodged at a faster rate because there's less shear strength. And so this is actually something that we have to deal with in New Zealand. You're driving along the road, there's another car driving along in the other direction, and it chips an aggregate particle out the corner of its tyre, and it goes flying through the air like a bullet, and it smashes your windscreen. So we have a lot of problems with window chips in New Zealand, but we're willing to accept that because it means we don't have to spend so much money on roads. It just means we have to get our windows fixed every now and again. So yeah, low shear strength. Now that's a problem because potentially there's lower durability because of the shear strength, particularly on sharp corners downhill where heavy trucks are braking. There's a lot of shear force there, and it's going to wear off the aggregate. Now that means that it's going to leave voids in the wearing course, which water can then penetrate, and it's going to cause potholes. So generally, chip sealing has a shorter lifespan than asphalt, and it all depends on how often the road is used, but normally chip sealing, you need to redo the chip seal almost twice as often as asphalt. It's maybe got half the lifespan. That's a generalization, but that's kind of the case. So there are some disadvantages with chip sealing. Now guys, the best way to learn about chip sealing is to watch a video. I've posted a video that I actually took on my honeymoon, if you believe it or not, on in the US, where I was watching some chip sealing, and I've put that video on YouTube. The link to it is on Moodle, so you get to see chip sealing happening in real time. It's very exciting. So this is a big issue though with chip sealing. You've got all of these roads over sparse population, which makes chip sealing preferable to hot mix asphalt because it's so much cheaper. But the big disadvantage is it has less shear strength. But this is the question: where do you need shear strength? Well, it's where there is the greatest shear force on the road. Where does that happen? It's where the road is going downhill and there is a sharp corner, because that's where cars are going to be going fast and the force of gravity is behind them, and then suddenly they're going to brake. That is going to shear aggregate out of the bitumen and the wearing course. And so one solution is you could actually have a hybrid road where all of the road where it's straight and flat, you use chip seal, but where you have sharp corners, you could use a hot mix asphaltic concrete. where you need a higher shear strength. And so you get the benefits of cheap chip seal and high strength hot mix asphalt. So that's a good way to go about it. I've got a final question here. Why don't we have more concrete roads? There's a few concrete roads around. You can see some here. And there are a handful of concrete roads in Erbil. Actually, the footpath, the driveway coming into Shaka where I live, at Naz City, that's a concrete road. Why don't we just make road wearing courses out of concrete? We've learnt about concrete. It's very strong. It's very durable. It sounds perfect, doesn't it, for a road? Why do we need another material like asphalt or chip seal to make a road wearing course? Think about that for a moment. It's got all of the properties, doesn't it? It's strong, it's durable, it's hard, it can have skid resistance, it's waterproof. The big disadvantage with concrete is it's very expensive. If we were going to build our road network through Kurdistan using concrete roads, it would be costing billions of dollars, not millions but billions. It's far too much cost. Concrete costs a lot more than asphalt, and that's the main reason why we don't do it. Concrete also does have a little bit of a disadvantage too. Look at that concrete road just there. Do you notice all of those squares? There's little grooves cut into the concrete. What are those? Do you remember from studying concrete with me? Well, those are contraction joints. Those contraction joints are when the concrete is drying and hardening, it doesn't form shrinkage cracks. It's basically dividing the concrete up into smaller blocks so shrinkage cracks don't emerge. Now, that can be a little bit annoying when you're driving. As I said, I've got a concrete driveway on Shaka Zakaria, and every 3-4 meters there's a big thick expansion joint. So what does that feel like when I'm driving over it? Well, every half a second I hear this du-du, 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 because basically I'm driving over a joint in the road. And so if all of the roads were made of that, it would actually be quite unpleasant because the road wouldn't be smooth. So why do we sometimes make roads out of concrete? Because they do exist occasionally. Well, the one advantage concrete does have over asphalt is that it lasts a very long time. It does not wear out, it does not get potholes. A concrete road could last 50 plus years, whereas an asphalt road might need to be replaced every 10 years, the wearing course. Now, that's a very important thing in certain cities where if you have a lot of traffic, you're going to cause major traffic jams if you have to close the road down for long periods of time to re-asphalt the road. I don't know if you remember last year they re-asphalted a 100-meter road, and there were terrible traffic jams through Erbil for several days while they were re-asphalting the road and the road was shut. It was awful. Now, concreting means there will be fewer roadworks. So in certain places, particularly in very busy cities where they don't want to have too much roadworks, they might choose to have parts of the road at least out of concrete rather than asphalt. That's the one advantage it would have. So guys, this is supplementary reading. It's not homework, it's supplementary reading, but pages 354 through to about 380, but not all of those pages in the Somayaji textbook. That goes through everything that I've taught you in this lecture. It goes into a little bit more depth than I've taught you, But remember, everything that I've taught you in this lecture is all you need to know for the online examination in a week's time. So guys, I hope you've enjoyed this class. I hope you've enjoyed Asphalt, and I hope you've got some questions to ask me in the tutorial on Thursday. Remember, in the tutorial during the Zoom class, I'm going to be going through basically a review of everything we've learned, so you're well prepared for the online exam. So guys, thank you so much. You've done so well this semester. Online learning in a pandemic is a tough gig, but you've dealt with it amicably well, and most of you have anyway. I've been very impressed with the quality of assignments you've submitted, and I'm looking forward to teaching you on campus. I think it's next semester in concrete technology. Thank you so much, and goodbye.